Okay, ladies and gentlemen, let's take a look at cylindrical shells. Thing to remember about cylindrical shells is cylindrical shells are poop. That's right. The way we're going to remember cylindrical shells is actually the word scat. Integration of circumference, altitude, and thickness, also known as scat. Now, scat is also known as animal droppings from their bottom ends. So scat, so cylindrical shells are poop. Now, we're going to use an example here, an equation. The equation we're going to use is f of x equals negative parenthesis x minus 1, the quantity squared, plus 1. Now, it looks like this if you graph it, but if you don't believe me, let's go back over here to Desmos. There he is. Very nice. So that if I want to flip this around the y-axis, I can. If I want to flip it around the x-axis, I can. It's going to be all good. So that's what we're going to be using. So close that. Get back over here. First of all, let's do this with discs and washers. Because if I want to do A around the x-axis, so I want to rotate around x-axis. Okay, well, the nice thing is, if I'm going around the x-axis, I'm going to have this shape here, kind of a lemon-looking shape, and it's going to go around like that. Okay, so that works out pretty nicely, and that's going to be the integration of pi, because in this case, we can use the disk method, pi r squared dx. Well, what's r? It's negative, parenthesis, x minus 1 squared plus 1. Now, not a lot of fun, but we can FOIL all that out, and it becomes a big, long thing. So integration from, and we would say, well, be from 0 to, well, where does it cross the x-axis again? I believe it's 2, but just in case, let's throw it up here. Yep, it's at 2. So we would say from 0 to 2 because we're going along the x-axis. So you would end up with the integration from 0 to 2 of pi goes out front. I'm going to say x minus 1, the quantity to the fourth, minus 2, parenthesis, x minus 1, the quantity squared, plus 1, all dx. If I went to the trouble to FOIL it out, it wouldn't be that big a deal. Can do it by hand. Okay, that's using the disk method. Now, if I want to go around the y-axis, so let's rotate around the y-axis. Okay, in this case, I would end up with this shape here and this shape here, and we would try to rotate it around like this. Okay, problem here. We have actually a number of problems. First of all, if I attempted to do the disk method here, I would have a washer, wouldn't I? Each one of these would be a washer. And I would have to do outside radius, inside radius. Now the problem here is the outside radius and the inside radius are actually the same function, so I have a big problem because this is a function with respect to x, but it is not a function with respect to y. So I can't even use the disk method here or the washer method because it's not a function with respect to x or y. Additionally, if I were to go around and do the disk method, pi something squared dy, I have to change this monster into something in terms of y. So I'd end up with y equals negative parenthesis x minus 1, the quantity squared, plus 1. So I end up with negative, or I end up with y minus 1, so negative y plus 1, square root equals x, and then I have to add 1 to both sides, and that's nasty. Okay, so that's nasty in and of itself. So that's a second problem. So it's a function, not even doable. Switching it to y's means switching it all around. That's a mess. What I need is I need a different way to do this. So what I'm going to do, let's expand our picture. 0, comma 1, 0. We have 1, comma 1 and 2, comma 0. So we have all of these. We want to go around this way. All right, now, Slicing this way is not going to work because it's not a function. But if I slice it this way, I'm still okay with that. I can totally slice it that way. Okay, so I can totally slice it that way. And what we have is we need a different way to think about this. The different way to think about this is let's do cylindrical shells. Cylindrical shells means take a whole bunch of cylinders and stack them up. But you'll notice I can't have this full cylinder because that part in the middle would be filled in. So let's take this cylinder and only make it about that thick. Only make it about that thick. And this way, if I only make it about that thick, I can do different size cylinders of different thicknesses and stack those up. Now, my pictures are horrible, so let's get a better picture. A much better picture would be this. You'll notice that if you rotate this around a y-axis, that if I have a cylinder here in the middle, but then this next cylinder, it wraps around it, and this wraps around it, and I can make the cylinders of different heights as they go all the way around. So by stacking them up, inside and outside, I can come up with an estimated volume under this very complex curve that I can't slice horizontally because it's not a function. I can totally slice it vertically, just not horizontally. So by slicing it vertically rather than horizontally, we can actually solve this problem. So let's take a look. Now, oh, by the way, another graph that might be helpful for us. Something like this. Here is basically our graph, and it shows that the outer cylinder is only going to be very, very short. So here we go. Let's pull this down. Our outer cylinder is going to be very, very short, but it's going to go a long way around when it comes back over. So this little cylinder out here looks like this. And then you have a higher cylinder here in the middle, and it goes around like this. And so you begin stacking these things up just like you see this red function here. So the idea of cylindrical shells is one shell stuck inside another shell, inside another shell. And if you find the volume of this wrapping plus the volume of this wrapping plus the volume of the next wrapping, you get a total volume. That's the idea. Let's put it to work in the next video.